Hey, it's Joel, the 3D printing nerd, and well, it's a fidget spinner video. But hold on, don't go anywhere. Don't go anywhere. What I try to do with my videos on fidget spinners is teach you something that you can apply to something else. And this definitely has that vibe to it because, well, look, this fidget spinner right here is using coins. This is using 5 pennies in each arm to it uses the weights. So it's not bearings and it's not nuts, it's coins. Pennies. I know not everybody has pennies, but at the, this is, you can use any coin if you want. It's just interesting. So that's cool. But the other thing are these caps. So this cap right here is locked into each other. And I got this idea because of 3D printing technology itself. 3D printing layers plastic, and there's those tiny little spaces in between the layers. And if one layer is stuck in the space of another layer, then it's almost like it is locked into place. Here, let me show you. So here are these two pieces. One has an innie and one's an outie, just like belly buttons. But because they're printed like this on the build plate, they have these tiny little layer inconsistencies. And if you put them together, you could almost hear it. There we go. And look at, they are locked into place. This is not coming out easily. And it's using this principle to put a cap on either side of this spinner, locking the cap through the bearing itself. It makes for a better spinner, but it's a really cool thing that you can now apply to other things. You could technically make 2 pieces. One has a little hole and one has a little outie here, and then when you put them together, they lock together. That's hopefully what you take from this, and you aren't necessarily using this to build another fidget spinner. At the same time, I'm not going to judge you if you're building another fidget spinner because, I mean, I just built another fidget spinner, but it's all a ways to a means to an end, or whatever that saying is. So here's what I need to do. I need to show you how to make this in Fusion 360. Making the fidget spinner itself with the coins is pretty easy. It follows the same tutorial as the bearings itself. You just stack them in there, and then because they're kind of all squished into place, they don't fall out. That's what that is. But regardless, let's do this, and let's show you how to make some cool stuff in Fusion. I'm gonna kind of rush through creating the fidget spinner with the coins because it's very similar in the tutorial I did to use the bearings. So let's just get started with that. I'm gonna create a sketch on this plane. I'm going to hit C for circle, and I'm going to drag it out, and I'm going to do 22.02, and that's the size of the diameter of the bearing, the 608ZZ bearing, and a little bit of wiggle room there. I'm going to select the line, or the circle. I'm going to hit O for offset, hit 2, and enter. And that gives me another circle around that one, and that's going to be the border around it. Now up here, drag out a circle. For this, the pennies, it was between 1902 and 1904 that I measured out. So what I'm going to do is 19.02. And you can probably guess what I'm going to do here. I'm going to select this circle. I'm going to hit O, hit 2, and enter. And that offsets it by 2. So now what I want to do is put a dimension of distance between this center and this center. So I'm going to hit D. I'm going to select this circle, this circle. I'm going to bring it out, and I don't want it to be too far away, so how about 30 millimeters? That'll be easy. I'm going to do a 2-point rectangle. I'm just going to go up here, and I'm going to drag it out like that, and that's easy. So essentially, just like in the previous tutorials, this is all we needed to do to create the fidget spinner itself. To finish that off, I'm going to hit E for extrude. I'm going to select the pieces that I want to extrude. I'm going to hit 7 for 7 millimeters. So I'm going to go up here to create pattern and circular pattern. It's going to be rotating bodies. So I'm going to select this body. And the axis is going to be the blue one, the Z or Z axis. I'm going to click that. There's 3. I'm going to hit OK. There they are. I'm going to select Modify, Combine. And I'm going to pick the elements that need to be combined into one body, and I'm going to hit OK. There we go. That right there is a fidget spinner with holes that are sized for the coins. Now for the caps though, this is where it gets kind of interesting. I'm going to create a new document here. For the caps themselves, we're going to create pieces that go into each other. And here's how I did that. I'm going to go sketch, create sketch, same axis, and then I'm going to hit C for circle. I'm going to drag this out and do 22. And it's going to be the diameter of the cap itself. Let's zoom in. All right. C for circle, drag it out. I'm going to do 11 because that's the size of the inner part of the bearing or the inner race. And hit C for circle, go to the center, drag it out and hit 8 millimeters because that's the inner diameter of the bearing race itself. I'm going to hit C, drag it out and do 4 millimeters. So here in Fusion, we've got 4 center circles. There is one that is 22 millimeters, one that is 11, one that is 8, one that is 4. And one last thing before we're out of here, we need to make a copy of this. So select it all, hit Control C, Control V. There we go. And then drag it over. That's it. That's all there is to it. So now we've got 2 copies. We can stop the sketch. They're very similar except for the 2 inner parts. So we can take this one and this one, hit E for extrude, and we can type 1 millimeter. I'm just going to make the pad itself a millimeter thick. No big deal. Now I need to bring back that sketch. I'm going to select this one, hold down Shift this one. I'm going to hit E for extrude, and I'm going to type in 2 millimeters because this is the part that rests on top of the inner race itself. This is where it gets different. This is where it gets different. So this one here and this one here, let's see, there we go. This one over here is going to fit inside of this one over here. The bearing itself is 7 millimeters in depth. So I think having these be 5 millimeters deep, each one of them, so that they can intersect is good. But since this is doing it from the plane, we need to make sure it's 5 millimeters above this part. So this is 1, but this is 2. So it needs to be 5 more than this. So we need to do actually 7. So let's hit E and go 7, hit enter. Oh, that was easy. All right, one more thing, this and this. These are the parts that are different from each other. Just select them, hit E for extrude, and do 1 millimeter. That's it. Okay, so now we've got these 2 caps. These are super easy to do. And they rest on top of the inner race, and they interlock with each other. The only thing that I would suggest at this point is to do a fillet on the pieces that intersect to make it a little bit easier. So select, go up to create, modify fillet, or you can hit F, and I'm gonna select this, and I'm gonna select this, and I'm gonna type in 1. Ooh, 1's a little too much. So Control Z, F for fillet, this edge. I'm gonna type in 0.5. That's a little bit better. There we go. Those should slide into each other easily, and the action of being a layered technology where the layers can interact and kind of lock into each other will aid us. So let's print this out and let's put it together. All right, the print was awesome. It came off the bed fairly easily. What I like to do is kind of hit it on the side with the sharp end of a chisel. And this way I don't dig into the PEI sheet on top of the build plate, but it knocks it hard enough to kind of just initially separate it from the PEI. I do use a little glue stick on my PEI, don't judge me. Now what we need to do though, now that we have all of this stuff right here, is we need to put it together. There's the caps. In fact, here, I'll show you in this camera right here. Here's the caps. You can tell that they are longer than that previous one, and those should lock in just great. But first things first, we do need to load our spinner with a bearing. I just happen to have some bearings right here. This one will do nicely. These are just standard bearings on Amazon. I got these pretty cheap, of course. I'll put the link down in the description so you can pick up your own. If you know your bearings well, please let me know if there's a way where I can make these spin faster. The ceramic bearings themselves are like 10 bucks a piece. Oof. So put this right here. It's nice and snug. Here we go. This should fix it. That worked. So now we've got a spinner with a bearing and it spins, but it needs the weights on either side. So find some pennies. 1, 2, I think it's 5. 5 pennies are what take up the space. So what we can do is just kind of, we'll take the first one, we'll kind of push it down. And then the second one, we'll push down. And then the third one, we'll push down. There's the fourth. And then the fifth one, right at the top, it's almost there. It's just really an excuse to use the mallet. 1, 2, 3, 4, 5. Good. All right, there's 1, there's 2, 3, 4, 5. Last one. Last one. All right. 1, 2, 3. We'll put the tarnished penny below, and we'll have the nice shiny penny right on top. 5. There we go. It spins pretty good. Not too bad. Now for the caps. This one should slide in fairly easily. Easy enough. So it's got that space right there. And here's what I want to do. I want to put this one and have it intersect with that space. And then I want to push it down. Just like that. That's it. That's it. We now have ourselves a spinner that actually has 5 pennies in each arm, and it spins. That's great. And what's really cool about this, there are some designs where it has a bottom so the coins don't fall out the bottom, but if they're snugged in really well, then they're not going to go anywhere. And if you're tired of it, then you can, I believe, you can take the pennies out. All right, that's it. That's it right here. I hope this is cool. I really like the idea of being able to 3D print something that interlocks with another thing that 3D prints. Plus, the fact that it's a layered technology means that the irregularities in the layers, they lock together, and it provides a really cool thing. So what if you design a case for your Raspberry Pi and it's in 2 halves? Well then, rather than using screws to hold it together, you can use this method to make something that it actually uses the 3D print itself to lock together. Well, if you're telling me, Joel, I want to get that apart, I think if you're ginger and careful, I think you might be able to. Maybe not. I'm not going to risk it. I'm not going to take it apart. I don't think it wants to come apart. Maybe. Oh. You totally want me to do this, aren't you? All right, this one's stuck. Okay, so maybe the technology... Maybe this isn't good for things that need to be taken apart more than once, right? Maybe you could use this in creating cosplay weapons, right? Instead of having to bond them together with glue, or maybe just as a way of keeping them together, you could glue them and then those hold it together and keep the glue in. I don't know. Hey, look, a fidget spinner. This was fun. It's late on a Saturday night before we watch some television for the night. I just thought I'd show you this cool thing. There you go. Hey, you know what? Thanks for watching. Don't forget to subscribe, ring that bell. Big thanks to my patrons, and thank you if you are the person that watches this channel with ad block. That's awfully kind of you. I really appreciate that. Finally, don't forget to hug each other more, because I love you guys. As always, high five.